It's now time to discuss the topic on research materials and how complicated it can be when you have many options to choose from, and even the possibility to reformulate some of your research sub-questions or research core questions. The chapter goes around the topic data, in terms of gathering or generating your own data, with experimental setups, with simulation results, with mathematical modeling. What is the nature and the complexity of the data? What's the availability? So that will define the sort of research material, but also the research strategy connected to the previous chapter. Here is where the researcher will confront different issues, complex issues that should be addressed. For instance, abundance and diversity of different types of materials. Also, the researchers should be resourceful, meaning that there must be new ways to generate or gather the required data for the project. When addressing the technical research design, the researcher also should make different types of choices, depending on the nature of the data, depending on the nature of the project. Those choices should be flexible, such that even your sub-questions or core questions can be reformulated, because the material could also define the type of strategy and the type of questions. It's an iterative process. There are, of course, advantages and disadvantages, pros and cons, depending on the material that the researcher chooses. For instance, you can decide that the way to proceed, it's an artifact that represents a prototype, a pilot that should be built in order to generate the data. That's one way to proceed. A different way is to generate a simulated environment and to test different parameters and see the performance of the artifact before it's being built. Both strategies, together with those materials, either the prototype or the simulated environment, of course, represent challenges. And even you can redefine your questions and sub-questions depending on the material that you choose. Now we need to be clear about something with the contents of the book that we are using for the course unit. It's highly oriented to social sciences, which means that we talk about sources and accessibility for the data for social sciences. But it doesn't mean that we cannot really apply the same concepts to engineering fields or to fundamental research. Now, in terms of sources to gather the data, these sources can be the research objects, the types of information, or actually where the information can be gathered. It can be empirical or deterministic. If we deal with types of information, well, those are facts or knowledge. And finally, the research object can become also the source for the information or the source for the data. 7 sources are provided for the data: people, the media, reality, meaning direct measurements based on your experiment, documentation, literature, or previous sets of data that is rigorous or was rigorously gathered, or even simulations. And that goes according indeed to the same process that we have in engineering, or the same process that we have in fundamental research. In terms of research material, then, there are 2 main decisions that should be taken. Of course, first, the sources, and secondly, how are we going to access the data in the sources? For instance, we are in a production line. There is a potential bottleneck. Now, how do we address the issue? We can talk to the operators, we can create questionnaires, because there are different teams, there are leaders. So we can create a questionnaire that will gather enough information from them because they are the ones that are experiencing the issue in the production line. But also we can create a sort of prototype with lots of sensors. And we can also gather the data from the sensors. So we can compare the opinions provided by the operators and the data gathered by the sensors. meaning that there is not only one source or there is not only one means to access the information from that source. Advantages and disadvantages, as mentioned before, are connected to the type of sources and the accessibility to the information from the sources. If you decide to run surveys, because that's what was proposed in a different paper that dealt with the same problem, then the survey needs to be well designed. There should be clear questions, not that so ambiguous for the operators. And also there should be a strategy to gather the information of as many operators as possible. Then you need to deal with the communication issue. So it has to be communicated to the leaders, managers, and then the operators will be well informed that they need to run and fill in the survey. Now, if you deal with designing a system for measurements, automatic measurements, also you need to study the sensors, you need to study the process, you need to know precisely what are you going to measure. Both techniques connected to the example are complex, and both techniques can provide different types of information, and that information can be used to answer some of your sub-questions. By now you should have realized that each of the chapters of this book is connected to a cycle. It's an iterative process, like any design project or like a fundamental research project. So research material is not deception. This is why we need to be careful when designing our research core questions and sub-questions, or our design questions. We depend a lot on the object and the types of information. It will really define our strategies and materials. For instance, once we have these questions and sub-questions, we need to determine which and how many sources are required, connected to each research object, connected to each research question or sub-question. For the cases we are exploring during the synthesis phase of the course unit, we will deal the majority of the time with a prototype, an artifact, a simulation, a compound, a decision toolbox, a serious game. Those can be the potential outputs of the project, connected to the sources, materials, and also strategies. The inspiration certainly should come from specialized literature, journal papers, books, official reports, patents. That should be enough for you to know which precisely methods and sources are we going to use to answer the questions or sub-questions. And even if we look at this cycle, once you understand precisely the methods and tools, and the methods and sources, then you will see whether your research questions and sub-questions should be reformulated. Again, this is a step-by-step approach, it's a cycle, and it's iterative. I cannot stop repeating this, but we need insightful bibliography in a research plan, research or design plan. That bibliography should be embedded all over the document. Introduction, problem analysis, formulation of your objective. Also methods and tools. That's the inspiration and that's what brings rigor. And it's not just the ticking the boxes as proposed by the book. It's not saying that you will deal with quantitative or that it's going to be a desk research. Certainly that's not enough. It's not enough to say that you are going to perform a simulation. You need to emphasize what type of simulation. It's not enough to say that it's an optimization problem. What type of optimization problem? Who else has dealt with a similar problem? It's not enough to say that you are going to deal with an experiment. What type of experiment? Where can I see an example of such an experiment? That level of detail is expected, not only for this course unit, but it's also expected in your professional life.